So today we are going to look at a problem which is a very interesting problem and very good problem. In fact, very challenging. So the question is that an ant on an elastic rope. Okay, that is it. The question says that a ant starts to walk along an elastic rope which is 1 kilometer long. Okay, the initial length is 1 kilometer long at a speed of 1 centimeter per second relative to the rope it is crawling on. While this happens, the rope is uniformly stretched by 1 kilometer per second. That is, after 1 second, it is 2 kilometer long. After 2 seconds, it is 3 meter long, and so on. Assume the rope will never break, and we have infinite amount of time on our hands. Will the ant ever reach the end of the rope? Okay. So let me explain you the question first. Suppose this end is tied, okay, and this is the free end, okay. So ant starts from here with a with its own speed, which is about 1 centimeter per second, and the rope itself is expanding at a speed of 1 kilometer per second. Okay, so this end is moving with a velocity 1 kilometer per second. So the question is, when will the ant reach to the this point, this free end, or reach, or it will reach or not, or if it reaches, after how much time? Okay, so this is the question. So you can give it a try. So you can pause the video right now and try to solve it, and then you move toward the solution. Okay, let me first clear you some things. If you know how to solve a differential equation, then you will be able to solve this. It is very simple one, simple linear differential equation. Otherwise, it may be difficult for you to solve this question. Okay, so let's move forward, try to see the solution. So see, so we have two ends of a rope, infinite of a rope which can be infinitely stretchable, stretched. Okay, so the ant is moving toward this direction, towards the free end, and the free end is moving in this direction with 1 kilometer per second. Okay, so we have assumed that the ant has traveled a x distance from the wall. Okay, the ant has traveled a x distance from the wall. Okay, so ant's velocity we have taken v as a symbol v ant, which is 1 centimeter per second. We have converted it in kilometer, like 10 to the power minus 5 kilometer per second. So total length of the this super elastic string at any time will be equal to 1 plus t kilometer. Okay, because 1 plus 1 t. Okay, so 1 t is what? 1 t is the distance traveled by the free end in t seconds. So it is the initial length, 1 kilometer initial length, plus length length expanding with respect to time. So here is the total length 1 plus t kilometer at any time. So speed of the ant, speed of the end point of the rope is 1 kilometer per second free end. We know that, and at wall. So the end which is tied to the wall, it is not moving at all. So its speed is 0 kilometer per second. So using Linear relationship, first of all, we need to understand that if this free end is moving with 1 kilometer per second and this end is not moving at all, then we can say that the points on this super elastic string, okay, the points on this rope or super elastic string must be moving with different velocities. Okay, because this free end is moving with higher velocity, most highest velocity, and the points behind it are having lower velocities, and this lower velocities varies linearly from this point to this point. Okay, so here is a very simple concept. You can uh, simply understand by your simple logic. Free hand has a higher velocity, and the tied one tied end has a zero velocity. So there must be a linear decrease of velocity. So we have used the fact that the speed will linearly decrease from the free end to the tide end. Okay. So at 1 plus t and at 1 plus t, matlab, I mean to say that at the distance of 1 plus t, the speed is 1 kilometer per second, and at a distance x, similarly by using linear relationship, it is moving with a velocity x upon 1 plus t kilometer per second. The point which is at a distance x meter or kilometer from the wall. So dx by dt will be equal to, so dx by dt is the velocity of the ant. Okay, so velocity of the ant is equal to velocity of the ant itself plus the velocity of the point where the ant is. So here is the total, our total velocity of ant is velocity of ant itself and the velocity of the point where the ant is. Okay, so this is our linear differential equation, first order linear differential equation. We have simply solved this. On solving, we get this. Okay, so x plus 1 by t. Okay. As ant reaches the end of the rope, x is what? X is the distance from the wall, and 1 plus t is the total length of the rope. So both will be same, x and 1 plus t, because when the ant reaches the rope, the distance from the wall of the ant will be equal to the total length of the rope. So this quantity will be equal to tends to 1. Okay. So v ant into ln 1 plus t will be equal to 1. ln 1 plus t will be 1 by v ant. Velocity of ant is 10 to the power minus 5 kilometer per second. Solving, we got e to the power 10 to the power 5 minus 1 second. So at this time the ant will reach to the free end of the rope. But this is a quite a long time, very very long time. Perhaps the ant will die, but again it is a hypothetical question. So it is just a hypothetical question. So we need not to think that the ant will die or like suppose whatever.